53. This I know is where you guys started to struggle a little bit because this problem, this numerator had a second square root, and that threw you a little. But the process that we follow is exactly the same process that we used in class. We are going to multiply. We are going to multiply this function by its conjugate. And we're just going to treat this like two terms. This is a term and this is a term. So we're going to rewrite that as our first term, x plus 5, and our second term is 5 under square root. Now instead of subtraction, we're just going to change that to addition. Okay. Same thing on top and bottom. So now let's do some multiplication here to simplify our numerator. Now, just like I did in my first example in class, I'm going to do this very step by step so you can see how this second square behaves. We're going to do square root of x plus 5 times square root of x plus 5. Okay, just like we talked about in class, squaring the square root symbol cancels it out, and we're just left with what's inside our parenthesis. So that's our first terms. Our outside terms is a positive square root of 5 times square root of x plus 5. Our inside terms would be negative square root of 5 times square root of x plus 5. Okay, and our very last terms, we're multiplying this times that, so we're squaring a square root. Okay. Negative times a positive gives us a negative, and we have the square root of 5 squared. Now these cancel each other out still. The square root symbol cancels with the exponent 2, and we're left with just the 5 inside. So I'm going to simplify this a little bit. I'm going to bring over my x plus 5. My middle terms cancel because they're opposites, and my last term is just a minus 5. 5s, and I'm just left with x in the numerator. So my 5s cancel. So all that complicated work, and we're left with just the x in the numerator. So let's fill in our denominator and see what we had all along here. In our denominator, we're multiplying. Okay, and I'm going to leave that as factors and just bring it over here. So now you can kind of see this come together and see how we're going to simplify. We've got the common x on top and bottom that divides out 1 over square root of x plus 5 plus square root of 5, which when we plug in, we've got square root 0 plus 5 plus the square root of 5. All I did was plug 0 in for x. Simplify this a little bit. I've got 1 over square root of 5 plus square root of 5, which gives me 1 over 2 square root of 5. Okay, the square root symbol kind of acts like a variable here. So like if we had x plus x, that sum would be 2x. So same thing here, we have square root of 5 plus square root of 5. That gives us 2 square root of 5. And I'm not going to simplify this because it's an irrational number. So here's the value of my limit. Now it's improper to have the square root in the denominator. So I'm going to rationalize the denominator. Okay. And what that means is I just want to cancel the square root in my denominator. And I'm just going to multiply the top and bottom by the same thing. Okay, so I'm just multiplying by 1 here, but I'm multiplying by square root of 5. And remember, these are going to cancel out. Square root of 5 times square root of 5 cancels out, and you're just left with the 5. So this is square root of 5 on top, because it's square root of 5 times 1. And then I'm going to show the middle step here. That's 2 times the square root of 5 squared. And this right here is going to cancel the 2 and the square root, so you're going to be left with square root of 5 over 2 times just 5, because you're just left with what's underneath your radical. 2 times 5 is 10, and that is your answer. Okay, number 55. Again, we're taking the limit of a rational function that contains a square root, and we're going to use our conjugate to simplify this function so that we can take the limit without getting 0 in the denominator. Okay. This example is probably looking a little bit more familiar to you. Our conjugate would be x plus 5 plus 3, x plus 5 plus 3. Okay. And hopefully by now you're kind of getting used to the way this behaves. Our first term is x plus 5 under a square root, but we're squaring it. So those cancel and you're just left with what's inside your radical. Our outside and inside terms cancel because they're opposites, and we're left with negative 9. Okay, and our denominator, let's just leave in the factored form. X plus 5. The factored form is always easier to work with, so we always try to leave it in the factored form if we can. Now, I need to simplify my constants in the numerator. That's going to leave me with a negative 4, so x minus 4 in the numerator. In the denominator, I have the x minus 4 times square root of x plus 5 plus 3. Now, after doing some work there, we can see that we do have a common factor that we can cancel out. That leaves us with 1 over x plus 5 and plus 3. Now hopefully we should be able to plug 4 into our function to take the limit. That's going to give us 1 over, plug 4 in here, that's going to be 4 plus 5 is 9. Okay, simplify one more time. The square root of 9 we know is 3, plus 3, that gives us 1 over 6. All right.